All right, let's go over your warm-ups. So again, we're putting together two separate means, two independent means and matched pairs. So you have to be able to identify the difference between those two. So that's really first course of action that you're going to want to be able to tell the difference. How can we know? How do we know? What triggers us that it's two means? What tells us it's two separate means? Two independent groups. You may not even have the same number of people in them. 13 men, 19 women, whatever. Two independent groups. Okay. What kind of triggers us that it's a matched pair? What are some of the things that... Before and after is a good hint. They're grouped together. So you have a subject who you have two pieces of data for. Okay, you have a subject that you have two pieces of data for. Then we're just dealing with the one mean of the differences. All right, so on page 30 in your packet, which was your warm-up, and so the first side is course anxiety. And so on this course anxiety problem, we were doing the a matched pair because we took the students' measurements before they took the AP course and after they took the AP course to see if they wanted to see if the anxiety decreased after taking the course. So since it is going to be matched pair, one mean, make sure that your parameter is defined with one mean and you have a subscript that's defining the way you subtracted, and I'm stating it here in my definition. So this is the average change or the average difference that in anxiety level after the students take the AP course, okay? And then I say how I'm subtracting. So the average change or the average difference in anxiety level because they took the AP course. All right. So now with our hypothesis statements, notice there is one mean. The null hypothesis has got the one mean equaling 0. That would mean the average is no change. And then, of course, we wondered if it was going to reduce. So the alternative is our less than 0. Okay, so our conditions and assumptions are about one group of subjects, that group of 16 students. So we have we get real about 16 things, randomly selected 16 students from this professor's students is stated. Independent, N is less than 10% of the population, so 16 is less than 10% of all this professor's students. Now, what is that extra special independence that we have for two means and matched pairs? Okay, so if there are independent groups, then each group's independent, but in this case, each pair is independent. So contextually, I'm saying each student's anxiety levels are independent of other students' anxiety levels. Okay, yes. You need to have it in context, yes. So don't just generically say each pair is different than the other pairs. Context is always better and more appropriate. Each student's scores are independent of the other student's scores. Yes?
Okay, so if it's a couple and you're interviewing them, we talked about that. Would it be that the couple, like the man and the female?
Each couple is different from the other couples.
Okay, so not of each other.
Correct, not of each other, right, because it's not an average for men and an average for women. All right, large enough it is not. 16 is smaller than 30, so therefore we made a dot plot. And so let's discuss the things I'll look for on this that are important. You need to make sure that you have included the labels, okay? That's essential. Furthermore, this x-axis label is not just anxiety level. If you just described it as anxiety level, all out. It is the difference. Those numbers are differences. These numbers are not a measurement of anxiety. It's the difference in the anxiety. So it's the difference in anxiety levels, and then define the way you subtracted post minus pre. Number of students on the left. All right, and so then remember you see what the range is, and they range from -3 to 1. So then you can do bars or your dots. So you put them in your bins. And I can see that the data is sun, somewhat symmetric, unimodal, and no outliers. So my approximately normal model applies. Questions there? Okay. So now this is a one mean t-test for matched pairs. This has to be there. Okay, if you just say one mean t-test, that's just like a regular old, just the average of one thing. But this is an average of differences of matched paired data. So that has to be in there. Okay, our test statistic was negative 3.92. Our p-value, 6.8 times 10 to the negative fourth, not 6.8. It was times 10 to the negative fourth. So that was 0.00068. And don't forget the DFT. T, not Z. Since it was one sample, it's N minus 1. Yes, ma'am. If it was not a matched, it was just a mean, it would be one mean t-test. Two separate means. So let me go over some, like the calculator, making sure we know where to find the calculator. So here's your menu. And the thing that I want to make sure that we understand is that if it doesn't say proportions, it's about means. So see, number 5 and 6 are about proportions. So numbers 1, 2, and 3, or 1 through 4, are all about means. Okay, so all that stuff in there. But we so rarely have, almost impossibly have the population standard deviation. And since we do not have the population standard deviation pretty much ever, that is why we're never going to be z-testing with means. Okay, so you're really using your 2, and that's the one for your paired data. And then number 4 is for your 2 independent samples. That's same thing down here, okay, for the intervals. If it says proportion, that's proportion. Otherwise, it's your means. So these were your means. No Z means. No Z means. T, not Z. Okay. All right. So there was our test statistics. So we then compare or obtain that p-value. I probably should not have rounded this. Should have kept it at 6.8. 2 significant digits. It is less than alpha, so I'm going to reject HO. So since it is less than alpha, I'm rejecting HO, and there is evidence that the average change, you can say the average change, the average difference, the average of the differences, all those kinds of things. But if you say there's evidence that the anxiety level has gone down, that's wrong. Saying the evidence that anxiety level has gone down, it's not right. Because look here. Did it go down for every single person? Oh, wait, that's not the right problem. It did not go down for every single person. Okay, so therefore, yeah, we can see that here. Look, these people, it didn't go down. So you can't say the difference that they have increased. It's the average that has decreased. Okay, questions there. Evidence that the average change in anxiety level after taking the AP course has decreased. All right, so there was that one. The second part of that asked us to do a interval. So go ahead and estimate how much it has decreased. So we have the parameter and assumptions the same as part 1. So 1 mean t interval for matched pairs. And remember when we put our little interval here, we're defining it. Whenever there's subtraction, we must define in front. So we have our mean over our post minus pre, and there we have it, and we must include the DF, okay? So I had people leaving this off on the past quiz. I think it was 22 that I graded. I hadn't graded 23 yet. People left off this in their conclusion. I am 90% confident that the average change in anxiety level after students take the AP course goes down between 0.62 and 1.63 points. Do you see how I didn't say negative numbers in here? I indicated the negative by saying that it's going down this much. Yes.
Could I say like the average before the course is 1.6 to 0.62 points higher?
see, because when you're saying the average before the course is that much than the average after the course, what does that sound like? You talk about the average before the course being this much different than the average after the course. That sounds like an average in front and an average in behind, two separate averages. So that's tricky. That's tricky. So if we want to really be clear and not run the risk of that ambiguity, we want to say that average change, or that average, how much it has gone down on average, how much it has decreased on average. Okay. And remember that intervals include the zero statement. So since 0 is not in the interval, this does further support that there actually is a decrease in the average change, or in the anxiety level. No, that's not right. There is a decrease in the average anxiety level. Okay. All right. Now, the second problem was about men's college GPA and women's college GPA and those averages. So this was two independent groups. An indication of that, I mean, they have nothing to do with each other. They are definitely different subjects. There are 13 men, there are 19 women, two independent means. So my null hypothesis, everything's going to be having my two means. I define two means. There's my hypothesis statements for two means. They asked if the women's is higher. So do be careful in how you put your information in. The way the information was given to me is it gave me men information first and women information second. So I'm kind of keeping in mind that I'm putting the men info first and I'm putting the women info second. Why does this matter that I'm kind of keeping that straight? Correct. How it goes into the calculator, so that when I do this, I need to make sure I have the sign the correct direction. So since I'll be putting men in first in my calculator, I'm putting it here first because that's the way it'll help me do it. Yes.
So I can write my hypothesis with subtraction too, right?
Yes, you can. You could write your statement like this with the subtraction, but it would have to have those two means. You would have two means. So, yep, that's equivalent. So now our conditions are about two sets of subjects, okay? So our randomly selected 13 men and 19 women is stated. And those 13 men is less than 10% of all such college men. 19 is less than 10% of all such college women. And here is where I'm saying that the men and women GPAs are independent of each other, that those two groups are independent. So neither one of them is large enough. Curse you. But they give us the histograms. So thank God we didn't have to do them ourselves. However, I can see from the histograms, provided that both distributions are somewhat symmetric, unimodal, and have no outliers or unusual features, so the approximately normal model applies. So there's that assumption. So this is a 2 mean t-test. And there's our t-score, negative 2.33. P-value is 0.015. Must include the DF. And it's a funky formula. The calculator gives you this. Okay, so that calculator gave you that number. It wasn't, like 13 plus 19 divided by 2 minus 1, or something even funkier, okay? So there you go. Calculator gives that to you. Now let's finish this out. We've got then a p-value who is less than alpha, so we reject the HO and have evidence that. See, and I can describe two averages here. I have evidence that the average GPA of all such college men is less than the average GPA of all such college women. Of course, I could state that differently. The average GPA of all such college women is greater than the average GPA of all such college men. Either way is equivalent. Okay, now to the interval. The parameters are the same. It is a 2 mean t interval, and define your subtraction. So I did the average of the means minus the average of the women. So there was my interval. Don't forget the DF, okay? And so I am 95% confident that the average GPA so I discussed it in reference to the men. So the average GPA of all such college men, is between 0.045 and 0.82 points lower than, because that's where our negative is counting for, the average GPA of all such college women. Two separate averages, okay? Matched pairs doesn't state about two separate averages, okay? And since 0 is not in the interval, this further suggests that there is a difference in the average GPAs of men and women. What happens if you have a 0 in the interval? Because neither one of these did, so how would we do that? Yep, there is no evidence of a significant difference. So, or, there is no significant difference, no evidence of a significant difference. There is no significant difference. It could be the same. There could be no difference, those kinds of things. Yes, ma'am.
So if the nearly normal model doesn't apply, I mean, like it doesn't click, like check off sun, but like we're gonna keep going.
Yep.
Do we just say it's not symmetric?
You can always say, I'm concerned that this condition is not being met, but if the approximately normal model applies, then go on. Yep. If you feel better about that, yes.
I have a question on the t-test. You know the one that's like the mu with the little 0 next to it?
Yes. So when you're doing a t-test and it gives you the mu with the little 0, that's your null hypothesis. That's what you're saying is, that's your null hypothesis statement. And this, you are saying that you are saying 0 difference, that's your HO.
So like almost all of them is just 0.
Yes. There actually has been one APFRQ where it was something, how much is it different than 1? And so you had to put 1 in there. But they, it just ended up taking off 1 point because like most of the country just does a 0 there. And that was only happened once ever, threw people off. But there you go. We're just going to go with that. All right. Yes. Let us go ahead and quiz.